Today, whatever you are, whatever you do, wherever you may go, you are a part of atomic warfare. It involves you, personally, in laboratories and in the field, in little-known places and ways. Units of the defense establishment of the United States are learning to work with atomic weapons, learning to strike, learning defense against the effects of atomic weapons. Blast, heat, light, radiation. Military units work continuously with the laboratories of the Atomic Energy Commission and their new weapon ideas. The services devise handling equipment and techniques that are practical and delivery methods that are deadly under any and all conditions of weather and warfare. 13 minutes from now, this airplane is going to drop an atomic bomb on your country. You will see it happen. You will know why. This is the record of military participation on an atomic test. Their objectives, their experiments, their results. Fall 1950. A fierce international war rips through a small country on the North Yellow Sea called Korea. Russia has successfully detonated an atomic bomb. Now the Alamogordo of the Ural Valley is a fact. Now more than ever before, the balance of international power rests with atomic energy, with weapons moving steadily from assembly line to stockpile, moving to hidden subterranean vaults to be stored, ready and waiting. But stockpiling alone in this day and year is not enough. We need to develop and produce a greater number and variety, and possibly even more powerful atomic weapons. Weapons tailored for specialized uses and targets. But like all new ideas and weapons, new atomic bombs, to be useful and practical, must first be tested. The Eniwetok Proving Ground is available, but problems of logistics make it difficult to run more than one test a year at this distant proving ground. What we need is a site closer to our stateside laboratories and available air support. Somewhere in the continental United States, close to home, a stone's throw from lab to testing field. But where? For a long time, as a matter of fact, ever since Trinity, men from Los Alamos had been eyeing the great barren stretches of the Southwest. This region, for the most part, fits the bill. Isolated from centers of population, with favorable winds, with the necessary consistency of soil and formation of earth strata below. And so beyond a World War II training base, to the north of an early-day Nevada stage stop called Indian Springs, 65 miles north and west of Las Vegas, an atomic range was established. A test site of over 400 square miles of flatbed valleys, mingled with mountains of solid rock, whose veins once colored history with gold and silver. A range remote from civilization, isolated, forgotten as the names of the men who once made their fortunes here. 5 times in the pre-dawn hours of January 1951, this long countryside came once more into international focus with Operation Ranger, the test of 5 atomic bombs. 5 successful airdrops that saved the weapons research program months of time, considerable money, and helped Los Alamos prove the radical new idea of small atomic bombs. Soon after Ranger, another use at the Nevada test site was apparent. This was a chance for the military to get more information on the effects of atomic weapons, vital facts. For what good are atomic weapons without full knowledge of what they can really do, and how we can be protected against their effects? The job of coordinating all military tests and supporting the AEC program at the Nevada site has been assigned to Special Weapons Command, a command that had successfully supported Ranger and has been in working contact with the AEC, as well as with all military units engaged in atomic research. So today, we in the armed forces have a test range close at hand and the opportunity to watch and note the effects of the atomic bombs to be detonated on and in and above Nevada soil. The armed forces are a full partner in the atomic test for the fall of 1951, Operation BusterJangle. And to take full advantage of this opportunity, we have a program of experiments and operations to seek out the answers of atomic warfare. Nevada test site. Baker shot, -1 day. For the first time since the era of ZI atomic testing began, we in the military have a full-scale program to answer the questions a military man must know about the basic effects of an atomic explosion on his material and equipment. Along the blast and thermal line, men of the various programs begin the job of placing their test equipment. Precisely arranged at predetermined distance from ground zero, men from the Corps of Engineers set up panels of plastics, paints, and coated fabrics, samples of various materials, tent cloth, inner and outer clothing, standard and impregnated materials. Lucite spheres built to represent a human torso in depth and density are located at 5 stations 2,000 to 8,000 feet from ground zero. Film and crystal dosimeters at varying depths within the spheres will measure ionization produced by gamma radiation. Foxholes become a priority project. Open and closed foxholes are spaced from 100 to 2,200 feet from zero. Protected and unprotected structures for the individual soldier are instrumented with film packs, gold foil, and sulfur samples to record gamma and neutron dosage. How and when materials ignite has been tested in many ways, but never before like this. Trays of typical refuse from the forest floor like leaves, twigs, and pine needles are to be exposed. We want to find what thermal energy levels will ignite these materials, what effect the blast winds will have on continued burning. What could we expect if enemy bombs were dropped in our forest? Fresh limbs of trees and dry logs should help answer our question. Kirtland Air Force Base, 1600 the afternoon before the first airdrop of the operation. This is not a test of new loading or drop techniques by the Air Force. Every man, every piece of equipment, every technique has been thoroughly proven during many months of practice runs on everything from uncrating the test units to dropping them on test ranges. The original atomic bomb and most of the test units since that time have been detonated on tall steel towers. The towers are costly and take a lot of time to build. On a test operation like BusterJangle, the gadgets that produce the nuclear explosions are not, in most cases, stockpile bombs. They are laboratory components, arranged in new ways. They are test devices placed in a common ballistics case to facilitate aerial drops. For the men of the Special Weapons Command, whose everyday job is working with the problems of handling and delivery of atomic bombs, the precision requirements of BusterJangle weapons are routine. A bomber positioned over a loading pit. A ballistic shape fitted carefully into a bomb bay. and an air crew to handle the thing in the air and drop it with incredible accuracy on a target in Nevada 12 hours from now. The bomber ready, it moves off to wait its takeoff time under double guard. Kirtland, Baker Day, 0100. Weather and operations briefing for air crews that will be entering their H-hour orbits in Nevada by sunrise. 3 hours from now.
This is a laboratory experiment and not the development testing of a new tactical weapon. H-hour is 0700 Pacific Standard Time. In addition to Rosebud, the drop aircraft, there will be 17 other aircraft in the vicinity at H-hour. Therefore, it is highly important that each aircraft commander adhere strictly to his briefed flight plan and orbit pattern. This is necessary in the interests of flight safety and so that each aircraft will be in a proper position to get his required data at H-hour. Due to the number of aircraft in the test area and the many necessary transmissions which will be occurring, it's necessary that you keep your transmissions to an absolute minimum. Know what you're going to have to say. Plan a clear, concise message, say it, and get off the air. When using operational frequencies, be sure to use code names only. Everyone has been thoroughly briefed in possible radiological hazards connected with this mission. Due to the small size of the bomb and the altitude at which you'll be flying, there is very little danger from nuclear radiation, thermal radiation, or blast effect. Flash blindness may be a temporary hazard, but if you wear your goggles as instructed, there will be no danger. Special aircraft such as the samplers, the trackers, and the terrain surveyors are more likely to pick up nuclear contamination. Crew members have been specially briefed and a radiological monitor is on board each aircraft. The aircraft commanders must work in careful coordination with the radiological monitor. Are there any questions? Colonel Ritland?
Gentlemen, the series of tests we are participating in today are unique in that this is only the second time that atomic bombs have been dropped within the continental limits of the United States. The general public and important people in our national structure will be focused on what we are doing. It is therefore particularly important that we produce an excellent mission. Within this operation, we have project officers and aircraft from the United States Navy and 7 Air Force agencies. You have been placed under my operational control so that we can be brought together to accomplish the mission as efficiently as possible. Each crew has been thoroughly trained in the technical aspects of your mission. This morning we have had a complete operational briefing for today's mission. With the background you have received and the training that you have attained on previous atomic tests, I am confident that you will successfully complete this mission. Now let's go and have a good mission.
First of the air operations to get underway is a C-47, with a job to do only in case the drop plane gets into trouble along the way. If the drop plane has to jettison a unit of fissionable material. These rad-safe, medical, and security men that make up the disaster crew will either land or parachute themselves to recover and protect the unit. The drop plane, Rosebud, is in regular communication with the disaster crew from takeoff to 0 hour.
Hello, Bottleneck. This is Rosebud. Go ahead, Rosebud. Bottleneck, this is Rosebud. Airborne is 0215, proceeding on course. Roger, Rosebud.
For the newspapers of the world, a headline rides in the cold belly of an Air Force bomber. Back at Kirtland, in what is known in the trade here as catfish control, in a very unspectacular routine way, every movement of that newspaper headline and all the other air operations for BusterJangle are carried out under the eyes of men seasoned by the experience of other atomic tests, Ranger and Greenhouse. All this coordinated with the Air Operations Center in the control point at the test site. Here, the positions of every plane in the area are plotted continuously. Their orbits in the sky above the test site must put them in a definite place at the time of the shot, in order to ensure airborne tests the same kind of planned position in relation to the burst as the military tests on the ground. In the crisp air of this Nevada sunrise, a news headline is about to be born. A news headline and more. A great deal more. The beginning of a regular schedule of tests to quickly proof test new ideas, to bring more powerful atomic weapons into being as soon as possible, to gain the know-how for the most effective use of atomic weapons, and for full defense against their effects.
5, 4, 3, 2, 1, 0.
While the rumbling echoes of the Baker blast still race across the Nevada countryside, the first radiological safety monitors leave by helicopter to survey the radiation levels in the target area and around the test setups. As their reports come back that the area is temporarily clear, the military effects people can move into the blast area to recover their samples. The Forestry Service men find the once solid log has become but a shadow, nearly vaporized by the great heat. The trays of forest fuels present an interesting pattern. Some gutted by fire, others virtually untouched. The paints, plastics, and fabrics have visibly recorded their response to blast and heat. Some of the panel racks lie twisted and broken on the ground, while the sections of material show the effects of thermal burning. Charred and blackened bits of equipment will become valuable data after study by our technicians. Woods and metals of various designs form the basis for a series of experiments on the geometry of thermal burning and their effects on backing material. So the Military Effects Test Group remains a vital cog in the machinery of atomic testing. Charlie Day. H minus 12 hours. We in the Military Biomedical Group begin the task of readying our test animals. These are the standard animals we work with daily in our laboratories. Knowing and working with them, we find that in many ways they are affected very much like humans when exposed to an atomic detonation. So these are our instruments, perhaps the most delicate of all instrumentation used during atomic tests. We completely anesthetize them for their mission at each hour. Our objective here is to correlate laboratory and field testing and determine the reliability of knowledge gained in our labs. to extend our information on the effects of thermal and nuclear radiation on skin, lungs, blood, the muscular and nervous systems. We can apply this data to the response of humans under similar conditions. Quite a difference here from a dusty coral road on Peleliu, the hedgerows of France, or a desert trail outside El Alamein. But beneath this desert floor in Nevada lies a minefield. A full variety of mines are buried here to give us much-needed information on the effects of an atomic explosion on emplaced mines under combat conditions. At Kirtland, another test device is loaded aboard its special transport, Rosebud. Not a weapon, but a theory. An idea in a ballistics case. Another step in atomic energy enterprise. Perhaps another way to increase the yield of the stuff atomic bombs are made of. The test site ready, the valley where the tall mushrooms grow is left to spend the night before the shot, alone. Operation BusterJangle, Charlie Day.
How's the shoot check?
Fine. Okay, sir.
You gather around for briefing. Major Mitchell will be our ad monitor again today.
Well, men, I would like to remind you that our primary mission this morning is to collect a sample from the cloud for laboratory analysis. The sample that we got on the last mission was very good. Our first penetration is always governed by the cloud dispersion and the velocity of the wind. According to the latest information, it looks like our first pass will be made at HR plus 1.5. Our altitude 8,000 feet. The communications gem that we used on the last mission worked out very nicely. I would like to continue to use them. Would also like to remind each of you to hand me your film badge at the completion of the mission. That's all, Jim.
Mitch, I'd like to add a thought to your briefing. We have a second mission to perform in this aircraft, and it's a very important one, at least as far as the Air Force is concerned. We're going to prove to everyone who has to do it that they can fly in this stuff and remain in this stuff as long as they observe a few safety precautions. When we are in the area around the cloud, the monitor will be the boss of the aircraft. Fellas, up to now, we've had 2 very successful sampling missions in our favor. You've all been briefed on the amount of radiation you can get and still be on the safe side. I'd like to assure you that you will never get enough radiation on the inside of this aircraft to give a thought to the consequences. Are there any questions?
Yes, sir. Is the special exit procedure when we get down the same as it was on the last mission?
The exit order will remain the same. Let's try not to touch the outside of the aircraft. And let's get over to the Rad Safe Center as soon as we can. Marvin, do you have your logs?
Sure, Jim. I'm ready to roll.
Okay, let's get aboard.
Zero hour, minus 3 minutes. From the bombardier's seat in the drop plane on its final run, we can see our target. The minefield line lays along our course, stretching east from ground zero. The blast and thermal line stretches out to the right, south, toward the control point. The military effects tests are ready. Airborne tests for the services are ready too. 9 miles to the south of ground zero, a C-54, codenamed Starfish, flies a course parallel to the drop plane. This is an airborne laboratory with a staff of doctors to test the effects of the bomb's initial light on the human eye. We want to know how to heal or cause the eye to return to normal after it has looked at a light that for a fleeting moment burns with 50 times the intensity of the sun at high noon. A variety of goggles and filter devices permit only certain degrees and wavelengths of light to reach the eye. The flash blindness experiment is ready. Below at the control point, other eyes wait.
9, 8,
And what?
7, 6, 5, 4, 3, 2, 1, 0.
The men and doctors set about their study of flash blindness. Out of this experiment will come considerable specific knowledge about protection and treatment for men of the armed forces and the citizens of their country. All of this even as the Charlie cloud continues to boil. As the cloud begins to drift and roam beyond the test site, high priority is given to the earliest possible recovery of some experiments and data, like the animals of the military biomedical experiments. When the okay from RadSafe is received, we move in rapidly to collect our animals. Time now becomes the most important commodity, for these are living, breathing beings. Although still completely out from the effects of anesthesia, they can only go so long without food and water. So they are quickly removed from their blast line stations and carefully carried to the waiting trucks. In another area not too far away, our test rats are removed from their electrically heated tubes. November nights in the Nevada desert are not exactly warm. This is but another project in our continuing research on the effects of thermal and nuclear radiation and its ultimate application to the effects and responses on humans subjected to atomic explosions.
Hi, Rat.
Hi, Paul.
How's the area for Shotgun 8 to come in?
The atomic cloud has moved over far enough, leaving the aerial space uncontaminated. The RadSafe monitors have checked the landing strip and found it radiologically safe.
Good. Shotgun.
Shotgun, Wilson.
The strip is clear for Shotgun 8 to come in.
Roger. Area is clear. We'll dispatch Shotgun 8 immediately. Roger. Okay, Rivers, the area is clear. Go ahead and get your aircraft into the air. Report into Shotgun when you're passing the course. Roger.
At the minefield, project personnel are returning with their monitor to recover and replace their mines. We hope that many questions will be answered for us about the bomb's effect on known types of U.S. and foreign mines, and countermeasures that can be perfected to ensure operational mines under all conditions. Offensively or defensively, the information gained here will play a vital role in future tactical situations. Shortly after recovery, the dogs, with their protective jackets removed, are snug in metal cages. They're on their way to meet Shotgun 8 for the trip by air back to their home laboratories. A great deal may depend on these animals. The vital facts and figures gained by our living instruments could mean the saving of many lives, perhaps yours and mine. These dogs will play an important role in formulating new healing techniques. For without them, we are handcuffed, unable to observe, study, treat, and heal. In the sky some distance from the test site now, the atomic cloud is still very much in being, colorful, in its own way fascinating, carrying with it the radioactive products of the fission explosion. The biography of every atomic cloud is essentially the same. The intense heat and violence of the fireball as it sears the sky causes the spectacular and colorful rust-like condition in the air around it. As the fireball cools, an enormous vacuum and afterwind is created, causing the desert floor to rise up into the cloud itself, to form the characteristic mushroom stem. The cooling also sets up a rapid condensation in the air around the fireball that sometimes produces layers of ice crystals, literally an ice cap. Knowledge gained on previous nuclear weapons tests has produced the theory that once the cloud has formed and stabilized in the sky, the vitally significant fission products in so-called unburned fission fragments don't distribute themselves evenly, but tend to collect in very large, invisible pockets, hot pockets, or cells inside the cloud. The particles that are suspended in these nebulous cells indicate many things that happen inside the bomb, as well as the efficiency of the fission reaction. So attempting to locate the cells and collect samples from them is a mission of the highest priority. Airborne by the winds, the cloud soon shears and spreads thin over an increasingly wide area. The radioactive cells become less concentrated, each one sometimes stretching over many square miles. They can't be seen, but will readily tip their radioactive hand to airborne detectors. Drone B-17s collected samples of the atomic clouds on Crossroads in 1946 and Sandstone in 1948. But on Sandstone, a manned aircraft accidentally encountered a good sample while tracking one of the atomic clouds. For Operation Ranger, all of the cloud samples were collected by manned aircraft. On Greenhouse, the test at Eniwetok in the spring of 1951, samples collected by manned aircraft equaled those gathered by drone planes. So manned samplers now have their permanent place in nuclear weapons testing, very probably replacing the pioneering drones entirely. At this moment, the samplers are orbiting at several altitudes a short distance downwind, awaiting the order for their first penetration of the cloud. Mounted on their wings and fuselage are filter boxes, holding chemically pure papers to capture sample particles of the cells, if they can be located. The men inside are standing by, making final preparations for their first pass through the Charlie Cloud. Their operations are based on considerations of each cloud individually. Their penetrations are ordered from the CP. Charlie Cloud, H plus 1 hour and 30 minutes.
Take a look, Hal. It's okay to me.
Okay, let's see. Say, that's Cream Puff 3, isn't it, Paul?
Yes, that's Cream Puff 3. How does it look?
Well, it looks pretty good. Why don't you have him try a first penetration?
That's okay, Hal. Let's try Plan 3, though.
Plan 3, is that okay, Hal?
Right.
Hello, Cream Puff 3. This is Keyhole. You're cleared to start first penetration. Follow Plan 3.
Visually, Cream Puff 3 seeks out and heads for the most dense portion of the cloud. His mission plan is simple. Before reaching the visible cloud, the sensitive survey meters in the plane start to climb as it enters the invisible field of gamma radiation that surrounds the cloud. If the plane misses a cell, the meters return to almost a zero reading when it emerges from the gamma field on the opposite side. If so much as the edge of a cell is touched, the plane is instantly contaminated, and the meters will continue to read comparatively high. The plane will continue to make passes until it has made a sufficient number to collect the required samples. Penetrations are delayed and spaced to keep personnel contamination to a minimum while collecting the vital samples. With a selection of radiation detection instruments inside, the monitor tries to locate and penetrate a cell of hot stuff in the cloud. For anyone who may ever have to work in the hot stuff, the most practical precautions are being tested and proven here on BusterJangle.
Keyhole from Cream Puff 3. First pass at Fox Jig. Ticket 600.
Cream Puff 3, this is Keyhole. Proceed with your second pass.
After an atomic cloud sampling mission, the skin of an airplane is highly radioactive. BusterJangle has provided further opportunity to proof test several solutions to the problem of a short and easy method of cooling off contaminated equipment. RadSafe monitors keep a regular check on the planes. In a few hours, the plane can be sprayed down with a special detergent known officially in rad-safe circles as gunk. On earlier atomic tests, such as Crossroads, decontamination of the sampler aircraft was an unborn science. The planes were sometimes abandoned for many months to cool off in nature's own good time. The experience gained and the quality of samples collected by these planes in the course of BusterJangle prove that jet aircraft can get the required samples with less personnel exposure. An aircraft that has become heavily contaminated from working inside an atomic cloud can be cooled off, made radiologically safe, and ready to fly another mission in 24 hours. Buster Dog. There is a continuous flow of information into Weather Central at the control point from all over the world, by wire, by teletype, by facsimile. The weather story is continuously written and revised on a global scale. In any test operation involving a radioactive cloud, the final decision to produce that cloud, to detonate a nuclear weapon, is always based on weather. We're looking for the most advantageous time for each detonation. Advantageous for test purposes, as well as the radiological safety of communities in the path of the cloud. Finally, the forecasts are compiled into a single report, a little volume compiled every 6 hours. For the Federal Civil Defense Agency, the Military Effects Program people have built and are instrumenting a variety of shelters that might be built for military installations in the field or in backyards for civilians. Some of the shelters are constructed of concrete blocks, some of wood, some of corrugated sheet metal. All of them have the additional protection of several feet of dirt piled on top. Through the night before 0 hour, as often as necessary, the test director and his staff will meet with the weather officer for briefing.
The winds at the surface are 330 degrees at 5 knots. At 10,000 feet, they're 330 degrees at 14 knots. And at 25,000 feet, they're 340 degrees at 35 knots. Taking this forecast over to our trajectory problem, we find that the red, blue, and black lines representing the 10, 20, and 30,000 foot levels of the cloud will take a south and southeasterly trajectory and will head right down south into Mexico. Taking this trajectory and transferring it to a map of a larger scale, I have here presented the 10,000, the 20,000, and the 30,000 foot levels. Each of these pegs indicate a 2-hourly movement of the cloud at these various levels. I believe, Dr. Graves, that's all that I have at this time.
Well, thank you very much. What do you say, Rush? Should we go ahead?
Favorable, Al.
What do you think, Duncan?
Already out.
Jack?
Okay by me.
And your planes operate with these winds, Ed?
Yes, sir. With this forecast, conditions look very favorable for us to establish our flight patterns.
What do you say, Tom?
We're all set, Al. The mobile teams have already started to shift their positions.
Well, Carol, I think we should go ahead.
Okay, Al, we have a shot.
Dog Day. H minus 2 hours and 30 minutes. Rosebud approaches the test site.
Hello, Keyhole. This is Rosebud. Over shotgun at 0430. Keyhole to Rosebud. Switch to channel 30. Keyhole, this is Rosebud. Going to channel 30.
Now, on the very high-frequency radio channel, a test site in readiness focuses its operations on the reports that come down from the drop plane. The same plane and crew that dropped the 5 bombs of Operation Ranger, the first ZI test.
Keyhole, this is Rosebud. Request information of the day.
Over the control point, the bombardier starts collecting the latest dope on winds, temperatures, pressures, and humidity at various altitudes. Information that will help him make the most accurate drop possible. There's a lot of work to be done before bombs away.
Hello, Keyhole. This is Rosebud. In target area.
The bomb is not yet armed. Final preparation of the test unit is delayed until the drop plane is safely beyond any inhabited area. While the weapon is put in readiness, Rosebud will hold an orbit pattern over the now deserted target area. The unit of fissionable material is monitored at regular intervals before being fitted into the weapon.
Pilot to weaponeer. We are depressurized. You may begin your IFI.
To permit in-flight access to the bomb bay, Rosebud flies at an altitude of 10,000 feet for its IFI circle, the holding pattern for in-flight preparation of the weapon. Up forward, the bombardier readies the bomb site well ahead of time. As the weaponeers, the ever-present midwives for nuclear weapons, start the job of putting the test device in a state of readiness for the drop. In the skies around the test site, all the other planes are present and accounted for well in advance of H-hour, orbiting their time in assigned patterns. 3 B-50s are on hand to develop airborne techniques for determining bomb damage, IBDA. Indirect bomb damage assessment, it's called. What they gain on these tests may eliminate the need for post-strike reconnaissance, risk fewer men, and fewer planes on an atomic mission. Inside the IBDA planes, they're working out the problem with equipment in standard use throughout the Air Force today. Though a radar beam will not penetrate an atomic burst, it may be possible to tune the radar screen in a way that will permit the clocks and camera in the setup to record ground zero, the exact time of the fission explosion, and the height of the burst. Aerial photographs will help determine the specific kiloton yield of a bomb. If ground zero, height of burst, and yield can be recorded by this combination of equipment. A couple of miles below, in Rosebud, the weaponeers are winding up the tedious and exacting job of putting the test unit in readiness for the drop. Nearby, men in the disaster aircraft, always within an easy call of the drop plane, can relax a little, settle down and wait for the show. From now until the weapon is dropped, its arming and firing circuits and unit of fissionable material are monitored continuously.
Pilot the engineer. Give us a climb power setting, please.
Rosebud is pressurized once more and climbing for the job to be done at altitude.
Tadpole 1, this is Rosebud. Go ahead, Rosebud. This is Tadpole 1. Request winds at altitude.
From the IBDA aircraft upstairs, the bombardier gets the word on winds and weather at bombing altitude. An hour and a half later, after 3 trial runs at altitude to establish the track it will make over the ground for the bomb run, Rosebud nears the end of the base leg of its final pattern.
Get ready to turn in 5 seconds. 4, 3, 2, 1, turn.
4 miles below, the experiments and observers at the test site sweat out the final bomb run.
Bombardier, would you open the bomb bay doors, please? Level. Minus 15 seconds. Get ready.
The entire operation now waits on the skill of this man. This bomb crew is allowed a maximum error of 200 feet from ground zero, with a 2-second leeway in time of burst.
Level. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
When the dust has settled back to the desolate target area once more, re-entry parties find the backyard bomb shelters have had their protective mounds of earth cleared off as the blast wave swept the desert floor. Shock, pressure, and radiation levels inside the structures proved that current designs for simple military and civilian shelters will provide servicemen in the field and their families at home with reasonable protection against the blast, heat, and radiation effects of an atomic detonation. The next blast, Easy Shot, will probably be the most powerful of all the Buster detonations. Taking full advantage of it to gain more of the hard-to-come-by knowledge of the effects of nuclear weapons on military targets, the Air Force is moving a B-17 and an F-47 into the vicinity of Ground Zero for Easy Shot to learn more about the effects of atomic weapons on planes parked on an enemy airdrome and how to disperse our own planes for minimum loss or damage from sudden attack with atomic bombs. Kirtland Field, Easy Day -1. This is the prelude of an entirely new and especially significant volume of military science. So this will be the first live nuclear weapon in history to be dropped from a jet aircraft. The secrets of the bomb have been and continue to be our most guarded secrets. In all our atomic energy enterprise, there is no priority higher than preserving the security of those secrets. It's a physical thing like guards and passes and security screens, and it's an individual thing in the minds and hearts of men. In an atomic test, as in the everyday duties of those who work with nuclear weapon development and technology, security is the highest obligation and responsibility.
Oh, that's fine. I'm glad it's all set. Okay, Sid, we'll be seeing you. Goodbye. Mac, that was Sid Newberg over at AEC. He's got some information he wants to talk over with us tomorrow morning.
Before we leave, Colonel, here's a essential elements of information report that came in just before you got here. I think we've got time to go through it if you'd like.
Yes, I think we should, Mac. With another shot coming off in the morning, it's good to know these things.
I checked with the FBI and the OSI a little while ago. There are still 5 known members of the Communist Party operating in our area, Zone 1, at the present time. They're the same 5 we've had for quite some time. They're still underground and still no indications of any organized meetings.
Along the Mexican border, there doesn't seem to be any significant movement of subversive elements into the country. Now, the picture in Zone 7 around Las Vegas indicates 2 members of the Communist Party registered at a hotel there yesterday afternoon. We have them under 24-hour surveillance. Indian Springs, for some reason, still appears to be negative. And that about sums it up.
The internal situation here at Kirtland seems to be good, too.
Oh, that's fine, Mac. Well, I suggest we call it a night.
That sounds good to me.
Okay, Mac. Well, thanks for staying down this evening. I'll see you tomorrow.
Right. Oh, good night, Colonel.
Good night, Mac.
Easy Day, dawn plus 13 minutes. Ground Zero in Nevada is only minutes away from Kirtland in the jet delivery wagon. History is airborne. As the B-45 heads out of the Albuquerque Sunrise, the air crews at Indian Springs get their pre-takeoff briefing, a final time hack, then make their now routine way to orbit patterns in the sky, to sweat out the last detonation of the Buster phase of this operation. 0 hour minus 30 seconds. B-45 Rosebud is on its final run to its target and to history. The easy target waits alone and unobstructed for its place in the chronology of nuclear weapons development. The military effects tests are ready once more for their individual H hour. A few hundred yards from easy target, a couple of Air Force projects bear mute testimony to the effects of the bomb on aircraft parked in the vicinity of Ground Zero. From study of these wrinkled skins, broken ribs, and backs, may come more positive knowledge, not only about dispersing planes on the ground, but about operating aircraft in the vicinity of an atomic blast. One by one, the military effects test setup open for re-entry. Takes to collect preliminary information. As early as possible, the Army engineers are going to put some of the samples from their water supply experiment through a system of filters and pumps to try and develop a practical system for making contaminated water usable once again for cooking and drinking. Water being as hard as it is to get many times, men in the field may depend on the techniques developed on BusterJangle for their survival someday. In the Air Operations Center at the control point, plotting teams stand by once more to map out the reports from aircraft on the various activities and conditions of the atomic cloud. From the ground, the movements of the cloud can only be observed for a limited time. In the air, it can be tracked over great distances visually and with sensitive counters.
Nutmeg 1, this is Keyhole. You are cleared off orbit at briefed altitude to start your operation.
The tracker flies a crescent orbit around the leading edge of the cloud at a horizontal range of about 20 miles. As with each type of air operation, there are several trackers flying at different altitudes, keeping track of the different layers of the cloud as it shears and moves with the winds of different direction and speed. Inside, ultra-sensitive ion chambers and scintillation counters maintain a continuous fix on the cloud. This kind of work will help make future predictions of cloud shearing and movement more accurate and provide the Weather Service with a means of studying wind currents and dispersion that was never before possible. Regular 10-minute reports are sent to the radio operator, who relays it to the plotters at the control point. Flying now beyond the range of the special very high frequency channels normally used for communications on BusterJangle, the message goes by key to the decoding operator in the Air Operations Center.
Keyhole from Nutmeg 1, Able 1, Baker 8, Sugar 35, Charlie 101, Dog 0, Easy .1, Fox 240.
Information reported by the trackers also helps civil and military authorities throughout the country determine areas and altitudes in the path of the cloud that should be avoided by their own air operations.
King 24 knots, love negative.
Nutmeg 1 from Keyhole. Roger, you're Able 1. Here's our first report.
Hours later, when the trackers are released, and the position and radiation levels of the atomic cloud are plotted out to 600 miles, all air operations are completed for the Buster phase of the test. The night following Easy Shot is only an interlude. Tomorrow, the people at the Nevada test site move in force to prepare for the Jangle phase of the operation. Never before have the armed forces had a site of their own and nuclear weapons to detonate as they wish. Never before has an atomic bomb been detonated on the surface of the ground or deep in the earth itself. One of the big questions that may be answered by the Jangle phase of the operation is the value of including contact or penetration weapons in our atomic stockpile. We have 2 nuclear weapons of our own test site, installations, and programs, formulated over a year and a half by the Armed Forces Special Weapons Project under the code name of Windstorm. The Jangle phase was originally planned for the remote island of Amchitka in the Aleutians. For reasons of geology and weather, it was canceled in Alaska and moved intact to the more ideal environment here at the Nevada test site. For the first of the 2 shots, the weapon will be detonated at ground level. The second will be placed 17 feet below the surface and covered to simulate the conditions of an actual ground penetration. A weapon detonated on or in the ground will undoubtedly produce a shock wave in the earth itself. But how much? How far? What will be the effect on the foundation of structures, on the earth itself? By instrumenting shafts of several depths in the ground, we hope to learn the story of blast and shock moving through the medium of Earth. We want to record the acceleration and degrees of pressure in the ground. In other words, how will the effects of these weapons differ from an airburst? What will be the amount and extent of radioactivity? How long will the ground area remain untenable from the unprecedented amount of radioactive fallout and residual contamination? A multitude of collectors, film badges, radiation detection and recording instruments at various distances from ground zero may give us the radiological story of the surface detonation. Another part of the story will be written in the work of the Army's water supply decontamination and purification experiment. To compare the effects of a surface blast with an airburst, many of the military effects setups used on the Buster shots are being duplicated. We're going to test every conceivable type of presently available military field clothing and future materials that may be used for radiological protection as well as utility. After 2 years of work by the Armed Forces Special Weapons Project to get the most information for the time and dollars spent, the all-military part of the BusterJangle operation stands ready.
Minus 30.
In the main control room at the CP, a network of clocks and timers are set in motion to warm up instruments, fire the weapon, and set the experiments and recording instruments in operation, each in a sequence that is precise to 10 millionths of a second.
Minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Rocket smoke trails form a grid in the sky to help us measure free air pressure. Radiation levels here are high, much higher than if this had been an airburst with winds to carry a great deal of the hot stuff away that had been left over or produced by the explosion. But as always, some information of extreme value to us can be had inside that dust cloud and in the crater itself, if we can get at it in a short time. Orbiting a few miles downwind, The men in a Navy P-2V are making an airborne evaluation of the radiological situation. They're working with all manner of devices to help develop easy and quick techniques and equipment that an airline transport or military plane can use to detect and stay clear of an atomic cloud. Like so many of the military tests, this is a continuation of experiments started on Greenhouse. Before the tons of Earth, suspended now in the sky, settle back to the desert floor, they're going to make some low-level passes directly over the bomb crater and drop instruments by parachutes.
Hello, Pelican 1. This is Keyhole. You're cleared off orbit to begin instrument drop. Over.
Roger, Keyhole. This is Pelican 1 entering area.
The men in the P-2V are the first to approach ground zero. With their instruments, they will record the first chapter of the radiological story in the target area and bomb crater. Instruments are parachuted into the area, which send back to the men in Pelican 1 a telemetered signal of their findings. The answers to radiological questions from the interior of the dust cloud that still hides the crater from the eyes of anxious observers. In a little while, ground monitors mark off the outer limits of personnel re-entry to the blast area and the distant surface shot crater. But there are some samples of soil from the fringe and interior of the crater that will be of the greatest value if they can be gathered up before they run the limit of their radioactivity. The eyes of a few men are going to get a close view, now, of this hole in the ground that once was ground zero. To make this possible, Army weasels, drone weasels, are warming up now for a sample collecting trip into the crater area. Sample gathering by remote control, observed and accomplished through the use of television. Mounted on the front of the weasels are compact television cameras that can be made to move in any direction, like the weasels themselves. One of the drones is fitted with scoops on the front, which will, hopefully, return filled with Earth samples from the crater area. They travel their own private road from the remote control station to the mound of Earth that circles the surface shot crater. The other weasel has a drill bit mounted on the back, which will be doing some remote-controlled digging for sample cores of the crater. For many reasons, it's important to know the fallout pattern and levels of radiation in the wake of every atomic cloud. To get the information that makes up the radiological picture of the terrain and the path of the cloud, the survey planes fly at very low altitude, about 600 feet above the ground, back and forth across the path of the cloud. They avoid the cloud itself, but have special filters loaded to catch invisible samples of fission products that might be lagging behind the cloud. They can monitor the terrain with ultra-sensitive detection devices, like scintillation counters, beta-gamma survey meters, and air conductivity instruments. Pieces of the picture are called in regularly, every few minutes to the plotting room at the control point.
Gopher 2 to Keyhole, cable 1-2.
Charlie 1340, dog 14, easy 8000, Fox.
Ground monitors are standing by to move into any areas the terrain survey planes may find to be potentially hazardous hotspots, after reworking them first from the air.
Request permission to rework areas dog 14 and dog 15.
Gopher 2 from Keyhole. Roger, you're able 1-2. Affirmative. Rework areas dog 14 and dog 15.
In time, the sugar site will be cleared for the kind of detailed study we want to make to evaluate the effectiveness of an atomic weapon detonated at ground level. For one thing, we hope from the knowledge gained on tests of the open and closed foxholes that a doctrine on the development of protective shelters for combat troops will be evolved, giving effective protection from blast, heat, and radiation for soldiers in the field. Now the push is on to get ready for the final phase of the BusterJangle operation, the last shot. It's going to come off 2 miles to the north of the surface shot crater at Uncle Site, location of the underground shot. Here in a semicircle around 0 point are 26 projects and 63 principal structures, perhaps the largest single military effects program. Once again, as in Greenhouse, the program is a joint one. The Army, Navy, and Air Force have joined in formulating a series of projects to obtain data on the responses of underground and surface components subjected to a subsurface atomic detonation. During the Greenhouse and Dugway tests of 1951, we were able to collect a sizable amount of information about the effects of ground shock and air blast on typical structural types. Now we are seeking experimental data from the other direction. An underground atomic blast. With the buster phase of the operation over and the surface shot completed, all attention now centers on structures. The scope of this one program can and will create far-reaching effects on the design criteria of future military and civilian building programs. For example, Army structures. From a 3-bay steel structure with a superimposed load to represent upper floors, the Army wants more information on damage and resistance to small factory and office buildings. Air Force structures. A 2-story reinforced concrete building. Here, the Air Force seeks information on the response of such building types and data to make damage predictions in possible target areas. 2 types of brick industrial chimneys will furnish facts on the behavior of masonry structures when hit by both earth shock and blast. At varying distances from 0 point, the Navy has buried standard utility distribution services: water, sewer, steam, electric, and gas mains. Some types are now in use throughout our cities and military bases. Others incorporate new developments for piping and connections. All these put under hydrostatic pressure to determine how these materials will withstand an underground atomic blast. A buried precast concrete fuel storage tank. How well will it withstand ground shock? What pressures will cause it to rupture? The Navy has a continuing interest in the problem of personnel shelters. These buried structures will get us a lot closer to eliminating the question marks of civilian and military protection during atomic attacks. A rigid frame building, a cylindrical arch rib structure, the beehive building. From these, the Navy hopes to justify specific design and construction formulas for the fabrication of adequate personnel shelters, with 2 types of runway surfacing, one precast and locked together with lengths of iron rod, the other a standard poured-in-place runway. The Navy will be able to make comparison tests of the effects of an underground blast on the 2 types. A few feet from the detonation point, several separate sections of concrete aggregate wall rest on a foundation like that required to hold a 5-story building. In a matter of microseconds after the blast, these walls will be shattered and thrown out from the target source in a rain of concrete missiles, hopefully to land on 2 blacktop collection areas. With this project, we're trying to learn how we can increase the radius of destruction from concrete fragments thrown out by an atomic explosion. The day before Uncle Shot, the bomb is lowered 17 feet into the ground to its platform. Here, for the first time, an attempt is being made to determine the feasibility of stockpiling a penetrating weapon. Once the weapon is in place, metal cover pans filled with dirt are placed over it to approximate the weight and density of the removed earth. Our instrumentation has been installed and the underground structures put under their earthen blanket. As the area clears, the feverish atmosphere that has characterized the site for many weeks disappears. It's quiet, and in a desert's own way, lonely. Shot day.
6, 5, 4, 3, 2, 1, 0.
Once the flash and dust of the underground shot becomes a thing of the past, and it drifts far away from the ground zero crater, preliminary ventures are made into the area by monitors of the RadSafe group. In the language of the radiological safety monitors, the area is hot. Too hot for any immediate full-scale recovery work. Because here, as in all other peacetime work with radioactivity, each man is permitted only a very small total dosage of radiation, far less than he could safely tolerate in a combat situation. These men know radiation. They live with it daily, here in the field and at their home laboratories. They have neither fear nor question. They just treat it with respect and observe a few simple precautions. Structures appear virtually untouched. Others are shattered and broken by the blast. The buried structures, of course, will remain as they are until we can return in full force to collect our data. For the time being, all we can do is be patient and wait for the radiation level to lower to a safe degree. Once it does, we will gather our facts and data and return to our laboratories for further study. This is a continuing job, this business of atomic testing. The scientist never stops in his search for more efficient use of our stockpile material. We must never stop in our work for more complete knowledge about the effects of atomic weapons. We don't dare. Military effects testing will continue on all atomic tests, equipment, material, and structures. Whether destined for military or civilian use, will be our test devices. A thorough knowledge of blast, nuclear and thermal radiation is our goal. This is our story of military effects. As we go back to our bases and laboratories all over the country, we leave the test areas as deserted as the ghost mines and towns of the surrounding Southwest that carry their silent memories of boom times and activity. But there's a difference. This remote valley in Nevada is going to come to life in history again, several times a year. There's much to be learned. Our job here has only begun. We realize this even more when we get back to home base with our instruments and data, and have the time to study the results of BusterJangle and evaluate the next set of military effects programs, and the next, and the next. While some of us in the Army, Navy, and Air Force start to work on future atomic tests, some of the rest of us are helping the Atomic Energy Commission develop the ballistics for yet untried weapon ideas, making them compatible with military equipment, devising and refining the equipment and techniques for ground handling of weapons before they have been proof tested, and grinding a polish into techniques for dropping these new atomic weapon ideas, sometimes using equipment for delivery that is standard today, and sometimes working with both the weapons and delivery wagons of the future, so that when they have been proof tested by the Atomic Energy Commission, the armed forces will be ready with the know-how to put them into immediate use. Combining this knowledge and confidence with the experience gained in operations like BusterJangle in working with the effects of atomic bombs, knowledge for the deadliest kind of atomic strikes on enemy targets, and experience for effective defense of our own cities and military installations, making the defense establishment of the United States a little stronger every day.